Welcome to the deep dive. Today we're tackling one of the most baffling aviation mysteries of our time, the disappearance of Malaysia Airlines Flight 370. It's often called the greatest mystery in aviation history, and honestly, even with all our tech, the big questions are still unanswered.
That's right. And our goal here isn't to add more speculation. It's really to cut through the noise.
Mhm.
We want to focus on the official investigations, the actual data, to understand what we do know, what we don't, and why it's still such a puzzle. We're drawing heavily from sources like the Australian Transport Safety Bureau's reviews,
Yeah.
their flight path analysis, and the public records.
Okay, so the basics. March 8th, 2014, a Boeing 777, 239 people on board, flying from Kuala Lumpur to Beijing, a routine flight. And then it just vanishes. What followed was this incredible story of data detection and, well, a really frustrating search. Okay, let's unpack this. So, the timeline. What do we know for sure about those first moments? Last voice contact with air traffic control ATC, that was 1:19 a.m. local time. Yeah. Over the South China Sea.
Right. And then, critically, just 3 minutes later, 1:22 a.m., poof, it's gone from civilian secondary radar.
Gone from civilian radar, but not completely invisible.
Exactly. And this is crucial. Malaysian military primary radar kept tracking it for another hour. And that data showed something completely unexpected. A sharp turn westward. It crossed back over the Malay Peninsula, flew out over the Andaman Sea. It finally dropped off military radar range at 2:22 a.m., about 200 nautical miles northwest of Penang.
Wow. Okay. So not just lost contact, but a deliberate deviation, it seems. That must have thrown the initial search efforts into chaos, right? They were looking in the South China Sea initially.
Absolutely chaotic.
Yeah.
Gulf of Thailand, South China Sea, Strait of Malacca.
Yeah.
Then everything shifted. Because here's where it gets really interesting. This novel analysis of satellite data.
Ah, the Inmarsat data. The famous handshakes.
Precisely. These weren't, active transmissions, just automated pings between the plane and an Inmarsat satellite, like a faint digital heartbeat. But analyzing these faint signals, the timing, the frequency shifts, it indicated the plane kept flying for hours. And crucially, it was heading south, far south, over the southern Indian Ocean.
So that data, those pings, became the only guide.
Pretty much the primary guide, yes. And that led to Australia taking charge of the search on March 17th. But March 24th, the Malaysian government made that somber announcement. Flight MH370 ended in the southern Indian Ocean.
And the scale of that search. I mean, we hear it was the most expensive in history.
It was, and still is. Unprecedented sums of money, resources, international cooperation.
Talk about the search area itself. The southern Indian Ocean, it's not exactly calm waters, is it?
Far from it. We're talking about one of the most remote and hostile maritime environments on Earth. Vast distances, incredibly deep water. We're talking, several thousand meters deep, plus notoriously bad weather, huge waves, strong winds. Just getting the search vessels out there and operating safely was a massive challenge.
So how did they even begin to tackle searching such a place? What was the methodology?
Well, the Australian Transport Safety Bureau, the ATSB, led a very methodical effort, detailed in their first principles review. The idea was to re-examine everything, all the evidence, validate it, and really pinpoint the most likely area. And it wasn't just the ATSB. They pulled in experts from everywhere. Data scientists, satellite communication specialists, accident investigators, Boeing engineers, sonar experts, oceanographers, a huge international team effort.
Right, and they started by mapping the seafloor.
Exactly. Phase 1 was the bathymetric survey. You can't safely tow sensitive equipment near the bottom if you don't know it's down there. They used ships, like the Fugro Equator, with hull-mounted multi-beam sonar to create incredibly detailed 3D maps of the seabed, charting underwater mountains, trenches, stuff never seen before.
Okay, map made, then what? Send down the robots.
Pretty much. Phase 2, deep tow operations. They use these specialized torpedo-shaped vehicles towed on long cables from the surface ships. These towfish were rated for depths up to 6,000 meters. That's nearly 4 miles down.
And equipped with sonar, I assume?
Yes, sophisticated sonar. They mainly use conventional side-scan sonar, which sends out pulses sideways to create images of the seafloor over a wide swath, about 2 kilometers. Some systems also had synthetic aperture sonar, or SAS, which gives much higher resolution images, down to like 10 centimeters, good enough to spot smaller pieces of debris.
And they had multi-beam echo sounders looking straight down to cover the blind spot right underneath the towfish. Were there other tools, like submarines?
Not manned submarines, but they did use autonomous underwater vehicles, AUVs. These are untethered robots, like underwater drones. They were particularly useful in really rugged terrain where towing the main vehicles was too risky, and later If the sonar detected something interesting, they deployed remotely operated vehicles, or ROVs.
Tethered ones with cameras.
Exactly. Tethered, controlled from the ship, equipped with high-definition cameras, lights, and manipulator arms. They could dive down, get a close look at a sonar contact, and see if it was wreckage or just, a rock.
That's an incredible amount of tech, but how could they be sure it would actually find the plane if it was there? Did they test it?
Oh, absolutely. Rigorous testing. They set up a specific test range on the seafloor with targets of known sizes and materials, including objects designed to mimic aircraft parts, like an engine core. Every sonar system had to prove it could detect these targets before it was used in the actual search.
And the data analysis, all the sonar pings coming back.
Constant analysis. Teams on the ships monitor the data 24/7. It was also streamed back to experts in Perth and elsewhere for double and triple checks. They classified contacts, level 3 for unlikely, level 2 for possible, level 1 for high interest.
And how many high-interest contacts did they find?
Thousands of contacts overall, mostly geological features, but they ended up with, I think, 39 level 2 and just 2 level 1 contacts that required closer investigation. And crucially, all 74 contacts investigated up close by ROVs were eliminated. The level 1s turned out to be an old timber shipwreck and a field of scattered rocks. Nothing from MH370.
So after searching that huge area, nothing.
The main priority search area, about 120,000 square kilometers, was covered with almost 100% high-resolution sonar. There were tiny gaps, maybe 3% due to terrain or equipment issues, but minuscule, really. The conclusion of that massive underwater search, stated in the first principles review, was stark. They had a very high level of confidence that the aircraft was not in that searched area, despite having over 95% confidence they would have detected it if it were there.
Wow. So back to the drawing board, focusing again on the data, the satellite data.
Exactly. The focus shifted back to refining the analysis of those Inmarsat signals. Remember the seventh arc? That line of possible locations at the time of the last satellite handshake, that was still key. The Defense Science and Technology Group in Australia, the DST Group, did extensive work using complex dynamic models of the aircraft. They used Bayesian statistics to figure out the most probable flight paths consistent with those satellite pings, the handshakes, the burst frequency offset, BFO, the burst time offset, BTO, all tiny clues.
And they considered different autopilot modes the plane might have been in.
Yes, 5 main lateral modes, like maintaining a constant magnetic heading or true heading, or following a programmed navigation route, LNAV. Initially, they sort of assumed all modes were equally likely, but the failed search in the southern part of the arc changed things. It meant the probability shifted. Scenarios that led the plane further south became less likely because, well, they hadn't found it there. This made modes like constant magnetic heading or constant true heading, which tended to result in paths slightly further north along the arc, seem more probable.
Did pilot behavior factor in what pilots usually do?
Yes, that added weight too. Advice from experienced B777 pilots suggested that LNAV or constant magnetic heading were common modes used in oceanic flight. This further increased the likelihood for that northern section of the probability map, roughly between 33 and 36 degrees south latitude.
Okay, so the likely area shifted north. Did anything else refine the search area?
Yes. Other evidence helped narrow the width of the likely crash zone around the seventh arc. Analysis of the recovered flaperon suggested the flaps were retracted, consistent with a high-speed impact, not a controlled ditching. Plus, BFO analysis hinted at an unstable flight path near the end, and simulations indicated very high rates of descent were possible. All this combined suggested the crash likely happened much closer to the seventh arc than initially thought, probably within 15 nautical miles, almost certainly within 25 nautical miles.
So a much narrower strip along that arc. Let's talk about the physical evidence then, the debris that was found.
Right, because pieces did turn up. Over 20 items, now considered likely or certainly from MH370.
The flaperon being the big one.
Absolutely. Found on La Reunion Island, way over in the western Indian Ocean, in July 2015, over 4,000 kilometers from the search zone. Serial numbers, internal markings found with a borescope. It was confirmed with certainty as part of MH370's right wing.
And other pieces followed.
Yes, off Mozambique, remember the no-step piece? And a flak track fairing. Part of an engine cowling with a Rolls-Royce logo off South Africa. Other fragments from Mauritius, Tanzania.
How did finding these pieces so far away help locate the crash site?
Through drift analysis, CSIRO, Australia's national science agency, did amazing work here. They ran complex computer simulations. They basically released millions of virtual debris pieces in their ocean models all along the seventh arc and tracked where they'd end up over time, driven by currents and winds.
And compared that to where the real debris was found.
Exactly, and also where it wasn't found. For instance, the lack of debris from the huge 2014 surface search, and the fact no debris washed up early on Australia's coast. That helped rule out certain areas. Crash sites too far north, between 32 degrees S and 25 degrees, didn't match the timing or location of the African finds. Sites too far south, below 39 degrees S, also didn't fit, as debris would have likely hit Australia or arrived later in Africa. The actual debris locations were most consistent with a crash site near the 7th arc, somewhere between 36 degrees and the 32 degrees S, clustering around 35 degrees south.
So combining the refined satellite data, the results of the underwater search, and this drift analysis.
It all pointed to a specific remaining area of high probability, a zone of about 25,000 square kilometers, again, centered around 35 degrees S along that 7th arc. That's where the experts agreed the most likely location remains, based on all available evidence.
Which brings us inevitably to the why. We have a probable location, but what actually happened on board? What are the main theories?
And again, we need to be careful here, sticking to what investigations considered. One major theory, discussed openly by officials, is murder-suicide by the pilot. U.S. officials reportedly considered it likely someone in the cockpit deliberately reprogrammed the flight path. Malaysian police named the captain as a prime suspect if foul play was involved. And there was the flight simulator data found at the captain's home.
Right, the simulated path that resembled the final flight path.
Yes, a path ending in the southern Indian Ocean. There was controversy about that being initially withheld, though Malaysian authorities later confirmed it, but stated it was just one of thousands of simulations and nothing sinister. Still, it remains part of the discussion.
What about mechanical failure or some kind of emergency?
Several possibilities were looked at. A power interruption scenario was considered because the satellite data unit, the SDU, went offline for about an hour before rebooting. Malaysian PM Najib Razak also stated early on that the transponder and other systems appear to have been deliberately turned off. Then there's the theory of an unresponsive crew, or hypoxia. The ATSB's analysis suggested this scenario best fit the available evidence for that long, seemingly stable flight south on autopilot after the turnback. No communication, no major course changes until the end.
And the flaperon condition supports that, doesn't it?
It does. The fact the landing flaps weren't extended is more consistent with an uncontrolled high-speed dive, perhaps after running out of fuel rather than a controlled ditching attempt.
Any other factors considered? Cargo.
The cargo was investigated. There was a large shipment of mangosteens, but more significantly, a consignment of lithium-ion batteries. We know those can pose a fire risk. And very recently, you mentioned the Hydrophone data study.
Yes, the Cardiff University research from May 2024.
Right. They analyzed underwater acoustic recordings from around the estimated impact time. They expected to find strong signals, similar to other known crashes, like Air France 447. Instead, they found only a single, relatively weak signal near one potential endpoint, which raises questions. Does it mean the impact was elsewhere or at a different time or perhaps less energetic than assumed? It prompts a reevaluation of those core assumptions.
It's just layer upon layer of complexity. So, stepping back, how did such a modern plane just disappear? And what changes has this tragedy forced upon the aviation industry?
The fallout was significant. There was, frankly, considerable criticism of the Malaysian authorities initially. Issues with communication, releasing conflicting information, delays in sharing military radar data, acting on the Inmarsat data. It hampered the early response. And the impact on Malaysia Airlines was devastating, compounded by the MH17 shoot-down later that year. It ultimately led to the airline being renationalized.
But on the safety side, concrete changes were made.
Yes, definite improvements. Global aircraft tracking standards were tightened by ICAO. Planes over the ocean now report positions every 15 minutes. New aircraft need autonomous distress tracking systems pinging location every minute if things go wrong. Inmarsat offered free basic tracking, too. There's still debate about making transponders fully automated, though.
And the black boxes, the flight recorders.
Crucial changes there. The underwater locator beacons, ULBs, on the recorders now need batteries lasting 90 days, up from just 30. That was a huge problem with MH370. The signal died before the deep-sea search really got going. Cockpit voice recorders, CVRs, on new planes must record for 25 hours, not just 2, capturing much more potential precursor information. And new aircraft designs need some way to recover recorder data before syncing, maybe streaming data in real time during distress or having ejectable recorders that float.
So real lessons learned, aimed at preventing another vanishing act. What's the latest on the search itself? Is anyone still looking?
Ocean Infinity, the private marine robotics company, started another search in February 2025. on a no-fine, no-fee basis, targeting a 15,000 square kilometer area based on the refined analysis. That search was paused in April 2025, apparently due to unfavorable weather conditions, not the season, but they expect to resume later this year. So the search does continue, albeit intermittently.
So here we are, MH370, a truly tragic event. Despite this massive, technologically advanced search, the most expensive ever, we still don't have definitive answers about where exactly it is or what truly happened in those final hours. The ocean holds its secrets tightly.
It really does. And maybe the enduring legacy of MH370, beyond the specific answers we still seek, is what it revealed. It showed the limits of our current technology when faced with the vastness of nature, yes, but it also showcased incredible human ingenuity, persistence, and international collaboration in pushing those limits. The drive for answers is powerful. It certainly makes you think, doesn't it? In a world that feels so connected, so tracked, how can something so large simply vanish without a trace?
A profound question indeed. It highlights the mysteries that still exist even in our modern age. Thank you for joining us on this deep dive into the enduring puzzle of MH370.